All right, ladies and gentlemen, welcome back. We are here today talking about the binomial model. So yesterday we talked about the geometric model, and the geometric model, we know it's geometric when they're asking a question that is something like, uh, when it, you're going to have a bunch of failures, what's the probability of this one being your first success? Okay, that's all geometric. The binomial model tells us the probability for a random variable that counts the number of successes in a fixed number of Bernoulli trials. So again, we want to be reading into the problem to make sure that it matches the Bernoulli trials. And as long as that occurs, we can make a binomial model happen when the question is framed in such a way that we're counting the number of successes in a fixed number of trials. So this would be something like me saying, what's the probability of getting 2 of these things out of 24, right? Whereas the other one was like, what's the probability of the first one getting, or the third one being a success? This one is like, what's the probability of getting 2 out of 24? So this is the binomial model. And you get a binomial model when when we have a fixed number of trials, right? So we have a fixed number of 24 trials, and we're saying what's the probability of getting 2 of successes, right? We'll keep it general, out of those 24, okay? So in a binomial model, there are 2 different parameters that need to be defined. The first is the n, that is the total number of trials. That would be the n, right? And the probability of success, p, for whatever that is. And again, the proper notation for this is binom n comma p. In your calculator, I think I want to say it's binom. I think that's actually the same thing. Okay. So, what does the binomial model look like? Well, first of all, we have to talk a little bit about this. This is a calculation that's part of our formula, the NCK. However, I'm not super concerned about this, okay? Like, you don't need to memorize this because I'm going to be totally honest with you. We're going to do all of this on the calculator, okay? So this is not super important that you recognize these things, but let's just bring it up. This says n choose k, and when you have n choose k, the formula for that would be n factorial over k factorial times n minus k factorial, where n is the fixed number of trials, k is the 2 out of 24, right? That's the k. In case you don't know what factorial means, factorial, so like 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, something like that, where you multiply that. Again, you're never going to make this calculation, so don't worry too harshly about it. I just wanted to make sure you understood what that looks like. Here is the actual binomial model that you will be using as part of your calculation. So this is p of your random variable x equals whatever your binomial model you're looking for is. N choose x, where n is your number of trials and x is the number of successes. This is the probability of success to the x power times the probability of failure to the n minus x power. Most important thing is that you recognize what this formula looks like and you be able to sort of transcribe the numbers correctly, because the actual calculations, again, are all going to be on your calculator. So this is what a binomial model is. This is your mean, also known as your expected value down here. And then here's your standard deviation. So your expected value on this one is n times p, right? N times p, number of trials times the probability of success. And your standard deviation is the square root of NPQ. Again, all of this information is found on a formula sheet that you get on the AP test. So memorizing it, not super important, but being able to recognize it for what it is and being able to use it, that's the important part. So let's do an example together here, and then we'll have and then we'll do a bunch more in class tomorrow. Okay. So let's go back to the spam example. Let's assume that your email is typical, 91% spam, 91% Pam, right? Pam is in your email. That's the problem. We'll also assume you aren't using a spam filter or a Pam filter. So every message gets dumped in you inbox. And since spam comes from many different sources, we'll consider the messages to be independent. So suppose you have 25 emails in your inbox. So notice a couple of things that they told us here. First of all, constant probability of success. P is constant. They told us independence, right? They told us independence. And we know that we get spam or not spam. So basically in the question stem here, they told us, yes, we can use Bernoulli trials. Because those are our three things for Bernoulli trials. Okay. What is the probability that 2 of the emails are not spam? So notice that they tell us we have 25 emails in our inbox. This is a fixed number of trials. It is this little context clue here that is telling us that this is a binomial model to be used. We have a fixed number of trials, therefore this is binomial. And then the question asks us, what is the probability that 2 of these emails are not spam? So, P of random variable equals 2. That's what we are setting out to find. Because we're saying there's 20, so we need the probability that 2 out of 25 emails is not spam. All right, so let's fill out our formula. Remember, the formula is P of big X equals little x equals n choose x of P to the, I'm going to go back, P to the x, just so I don't mess it up. Right, remember, you don't need to memorize it. Times q to the n minus x, right? N minus x. Okay, so the n and the x we know. The fixed number of trials is 25. That's our n. We're looking for 2 of them. That's our x. So this is 25 choose 2. Probability of success. What is our probability of success here? Success is being determined by it being not spam. So in this case, since 91% are spam, a success is 0.09. So that's 0.09 to the second power times 0.91 to the 25 minus 2 power. Stop it. There we go. And we figure that thing out right there. So we can do this calculation. 25 choose 2 is a button in your calculator. I'll show it to you tomorrow. Again, what I'm really going to show you tomorrow, though, is the calculator command that kind of does this for us. So I'm doing that in my calculator right now, and I come up with 0.277 as the solution. And I will show you that trick tomorrow in class. Okay? Alright, so that is the probability of 2 out of 25 emails being not spam. 2 of the 25 emails are not spam. It's a 27% chance that that happens. Alright, what about this second one? What is the probability that 1 or 2 of the emails are not spam? So notice that it's asking us for 2 specific cases. What's the probability that 1 of the emails is not spam? What's the probability that 2 of the emails are not spam? And that or statement in between, remember, tells us that we really should be thinking about the plus, right? That we're adding these 2 emails together. So what is it I'm trying to find? I'm trying to find P of x equals 1 plus P of x equals 2. So I'm going to use this formula for the 1 and this formula for the 2, and I'm going to add them together. We actually already know this one though, don't we? We figured that out in the previous problem, so that's actually 0.277. So we'll be able to just add that up. What we really need to do then is just p of x equals 1. So let's use the formula again. 25, choose 1. Probability of success is the same thing, except this time it's to the first power. And that's times 0.91 to the 25 minus 1 power. And again, and then we're adding 0.277 to that because that's the p of x equals 2. So I'm using my calculator to figure out what this first one is, and that is 0.233 plus 0.277, which is 0.510. 511. Rounded correctly, 0.511. So to find the probability of 1 or 2 of the emails, we needed to figure out the probability of 2 emails and add that to the probability of 1 email. Well, we figured out 2 already. That's what we did in the previous problem. So no need to do it again. And then we found p of 1. We added those two things together. Finally, the last question, find the expected value and the standard deviation of the number of real messages you should expect in your inbox. So let's just look at the formulas for that again. Expected value is n times p. Standard deviation is the square root of n p cubed. So, wrong direction. The standard deviation, excuse me, not standard deviation, the mean is n times p. That's 25 times 0.09. So that is 2.25. And then my standard deviation is the square root of npq, which is 25 times 0.09 times 0.91. And we're going to do that. 0.91. And I get 2.0475. So this has an average of 2.25. So out of 25 emails, I should expect to get about 2.25 of them to be real messages. And that's going to have a standard deviation of 2.0475, which if we can assume a normal model, and we're going to bring up the normal model again in a couple days, that means that I can expect anywhere from 4.25-ish to 0-ish. I can expect 68% of the time I check my email to get anywhere between 0 and 4 emails being the actual real emails when I have 25 mails in my inbox. Okay, Tuesday in class, tomorrow we're going to do a bunch of problems with binomial and geometric models. I'm going to show you the calculator trick, and then that's all of the stuff that I just talked about. And then we're going to move on to the normal model. Okay, so we're going to do that on Wednesday, and then Thursday, Friday this week we're just going to do a bunch of problems. So here we go. I will see you guys tomorrow.